A model is a mathematical description of an authentic situation. We say that the description models the situation. So a model being a mathematical description, what does that mean? Well, for us, it's going to be like an equation. It's going to be an algebraic equation that's going to model that real life situation. Okay, and then a linear model will be one that we're working with in chapters 1, 2, and 3, which is the model that you come up with is a line. We won't always be working on lines. We're going to be working with exponential functions in chapters 4 and 5 and quadratic functions in chapters 6 and 7. But at this point, and actually some other ones in 8 and 9. So we're talking about linear models for chapters 1, 2, and 3. So the authentic relationship is going to be a line. Now the smokeless tobacco one is a linear model. Why? Well, because a line fits the data points well. Therefore, it must have been linear. Right? That's what this line is that you look at. That's a linear model. Model because this is real data, linear because it's a line. Oops, I went too far. Now, every linear model is going to be a function, or linear function. Why? Well, because linear models are always diagonal lines, and diagonal lines, we learned in chapter 1, are always functions no matter what. So functions are going to be used to describe situations and to describe relationships. So we're going to do them in real life situations. So with like story problems, that's what this is saying. So to describe situations, story problems, and to describe mathematical relationships. So we're going to do both. Mathematical relationships being, the normal algebra thing. All right, so let's look again at the smokeless tobacco data. The scattergram has been drawn again with a linear model line, and hey, there's that point that was missing before that I made a blue dot out of, the 11 one. There they are. So we're going to use that model, the linear model that's drawn, to estimate the percentage of 12th graders who've tried smokeless tobacco in 2015. All right, now the really interesting thing here is that it gave you 2015. So let's think about that for a second. 2015, take away 1990, because that was our starter year, is 25. So we want to go to where t equals 25. Right? So you take your graph and you kind of, well, I'm going to insert a line here so you can see it. Okay, here's 25 right here. I'm going to go up like that. I'm going to make it orange. There we go. Okay, so there's 25. Now that's a t value, and t was our x. So then what's the y value that goes with it? Well, that would be over here. Oops, I made that a little high. There we go. So it looks like the percent, which is what we were actually asking about, is about 5, right? So I guess the answer really is about 5%. That's the actual part that they were asking about. So they gave you year. So you go to the year axis, which is the x-axis. You find the 25. You go up, find the curve, the line in this case, go across and figure out where it hits the y-axis, or in this case, the p-axis. Okay, use the linear model to estimate when 20% of 12th graders had tried smokeless tobacco. So notice I'm not giving you time this year. I didn't give you a year. I gave you 20%. So the p is equal to 20. Now it's the whole number 20. It's not 0.20 because that y-axis uses the whole numbers, right? So we want 0.20, or excuse me, we don't want 0.20, we want 20%. So I'm going to go to 20%. I'm going to have to change the color here so you can see it a little bit better. How about green? Green looks good. So there's 20. And I want to drag this in. There you go. And then I'm going to make another line that matches it. So 20 kind of hit the line right there, and I'm going to make it come down and hit the x-axis. And it looks like it hits around 12. So the time is about 12, which means the year is about 2002, right? Because 1990 was your starter year. You take 1990 and you add on 12, right? Because that was 1990, that's 1995, that's 2000 right there. So in about 2002. Now, hopefully you've noticed that this is terribly inaccurate what we're doing, right? We're just making guesses, and they're not very good at that. So we're eyeballing, right? Because we're using our eyeballs, literally our eyeballs, and some pencils and paper to do this rather than having a formula, it's not as good, right? So we're just guessing, which means we won't be perfectly accurate. It would be better if we had an equation for the line, preferably one that used all the points. Wouldn't that be better? I think it would be. So that's our plan, which I believe is the next thing. Haha. Coming up with the equation of that line. So there's a line. It's called the linear regression line, line of best fit, the least squares regression line, whatever. There's one line, and it's the one that the computer's drawing right here that is the best line, right? It's the bomb. It's the one we want. It's awesome. But we need to be able to come up with its equation, and it would be great if it used all the points, not just two of the points. We all know how to find the equation of a line from 2 points. But I have all of these points right here in this table. I want to use them all. That's all real data, which, by the way, this is real data. This, came from the real world. I want to be able to use all of it. So I'm going to use my calculator to do it. Now I have the instructions right here, but I'm also going to do it with you. So you grab your calculator, you go to Stat. Now see how number 1 is dark? That means you can either press Enter or you can just hit the number 1, either way, and you're going to get Edit. And then you type in your data. But we've already typed in the data because we already did this problem, but type it in if you hadn't already. So Stat, Edit, enter the data. That's step number 1. And 2 actually. Enter the independent variable in L1, the dependent variable in L2. That's what the L stands for. It stands for list. List 1, list 2. All right, when you've got it all in there, you press Stat, go to the right to Calculate, pick number 4, which is linear regression. So you can either go down, 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 get it so that the number 4 is dark and press Enter, or you can just press the number 4. Either way. Now, you have a choice at this point about what you're going to do. Now, a couple of things. 1, I'm working on the old operating system. Now, the old operating system looks like this, where it has linear regression, ax plus b, and it has blink, 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 and it's waiting. That's actually the worst system to work with, but that's what I've got on this computer. So, what you do is you press variables, y variables, number 1 function, number 1, and it'll say linear regression y1 and press Enter, and that's optional. But the advantage to it is that if I go to y equals now, it actually put in that equation. It's just sitting in there waiting for me with all its decimal places. Nice, huh? Okay, so again, let me redo what I just did. There it is. Now the R squared and the R thing, those are on mine because that's some statistic stuff that we use. You can just ignore them. They're not important for a 131 class. If they're on there, ignore them. If they're not on there, don't worry about it. So the R squared and the R, the bottom 2 rows, that's something we cover in statistics. But A and B you are interested in, because A and B, A is your slope. Look, it's y equals ax plus b. A is the slope, so you'd put that number in for A. B is the y-intercept, so you put that number in for B. All right. So using that smokeless tobacco data, there it is, find the equation of the line. Now the kicker is that you can't say y equals mx plus b. Every student wants to, but that's not what you get to do. You have to use different letters. So instead of y equals ax plus b, we're going to use p as in percent equals at as in time plus b. So p equals, a was negative 1.189 t plus 35.113. You never want less than 2 decimal places. Usually 2 and 3 are pretty good, sometimes 4, but in general, a couple, like 2, 3, 4, those are the kind of decimals you want. Don't round to 1, and don't write 17 of them as a general rule. If we err, we actually err on the side of too many decimal places, not too few. All right, there's your equation. Make sure you make a note to yourself. As a matter of fact, I'll make a note right here. Note, use the variable letters given in the problem. Okay? Do not use y and x. Story problems almost never use y and x. They're going to use p and t. All right, now we can verify that this is a good model, or excuse me, how can we verify? We can make a scatter plot with the line drawn. Let's do that, shall we? So if I go to y equals, now if I hadn't stored it with the y1 thing, which let me remind you real quick, stat, calculate, number 4, linear regression, you tell it variables, y variables, 1, 1. So if you didn't store this, you can still get around this, but I just want to mention real quick, those of you that have the new system, it's actually easier for you. What happens is it's going to ask you, what's your x list, what's your y list, what's your store equation. That's actually one of the things. So it'll say store EQ, store equation. And you just do that thing I just did for the y1, you put it right there in the store equation. And then you go down to calculate and press enter. This computer program won't show the new operating system, but that's how you do it. Okay? So if the new system, the y1 goes under store equation. The old system, you're stuck doing it this way. So when you run it, it'll automatically store it for you right there. So I have my plot 1 on, so that means I'll get a scatter plot, and I've got this equation in, so it'll make that equation of that line. So I'm going to press zoom 9, and it'll graph it. And then to show it, you'd say, well, I'm going to draw a picture of it with the line drawn, and you as a student will just draw a quick sketch. I, of course, have this program, so I'm able to just copy and paste it in. So we can make a scatter plot with the line drawn and show that the line does a good job of, it's not really going through the points, but modeling the points. Cool. There we go. And yes, you do need to draw that picture. I mean, that's how you show your work. You show your work by drawing that picture. Quick sketch of what you're doing. All right, next. Estimate the percent of 12th graders who used smokeless tobacco in 2001. Label it on the graph, and what is the error? Tricky. Okay, so this is talking about 2001, so let's think. This is t equals 11, right? Because 1990, here, I better take it. 2001 take away 1990 is equal to 11. So t is equal to 11. I'm giving you time right there. That's time, years. And then I'm asking for percents. So you'd use your model. You'd say, okay, it's negative 1.189 times 11. Oops. And then instead of t, you're going to put in 11 because that's the year. And then you use your calculator and find what that is. Ooh, here's another point. There's an advantage to using, if you stored it, it'll be second table right here in your table. If you go down to 11, so if you use the store equation, then the table will show you. By the way, table's not the same thing as stat edit, just so you're clear. Tables above here, above your graph button, that's using this line, this thing that you put under y equals, that y1 right there. Y1 makes your table of values. That's why it says y1 at the top. See right there? As opposed to stat edit, which has a completely different setup, right? L1 and L2. So according to y1, it should be 22.3, I think it was. Let me go back. 22.032. 22.032. Now, what's the error, and let's label it. Well, I don't have time for that, so I'm going to have to do that in the next video. I'll catch you right there then.